So here's our potentiometer circuit. We have power coming from the laptop and USB into the Arduino. We have our 5-volt and ground pin giving power to the breadboard. Over here we have our analog pin that gives power to the wiper and allows you to sense it, as well as our 2 jumper cables here connecting the 2 ends of the potentiometer to the positive and negative side. Over here we have our jumper cable from digital pin 3 going over here, coming through the limiting resistor and powering our LED, and that jumper cable goes back to the ground. Here's our potentiometer circuit program. At the top here we have our sensor pin and LED pin. Those variables are getting declared and initialized. In our void setup section we have our pin functions getting specified. It's an output, as well as our serial begin function with a 9600 baud rate. Over here we have in our void loop section we have the sensor value for the wiper, and it allows it to read the value of the wiper, and then our serial print function, which will print out the value of the wiper, the voltage, to the serial monitor. And then we have our if else function. So if the sensor value is greater than or equal to 600, the pin will turn on, or the LED. Otherwise the LED will turn off. So right now, as you can see, it's over 600 and the LED is on. Now if I go ahead and adjust it so it's below 600, the LED is off. Just again, over 600, and it's back on. Here's our VEX line tracker circuit. We have our VEX line tracker here. It has its 3 wires, white for control signal, red for 5 volts, and the black for ground. Over here, our Arduino is getting powered by the laptop and USB. Our yellow jumper cable here is attached to the 5-volt pin. Goes to our breadboard, and through this blue jumper cable into our VEX line tracker. Our green jumper cable, our first one, comes from the ground pin into the breadboard, goes through this blue jumper cable and into the VEX line tracker. And finally, our second green jumper cable comes from the analog pin and directly to the VEX line tracker's control signal. So here's our VEX line tracker program. We have our sensor pin variable getting declared and initialized at the top. Our void setup section has the serial begin function with a 9600 baud rate. Then in our void loop section, we have our sensor value getting placed as an integer. This allows the control signal, the value of the VEX line tracker, pretty much to be read off. And then we have our control statement, the if else control statement. So if the sensor value is greater than 800, then black object detected will be printed. The sensor value is less than 100, the white object detected will be printed. And if none of those are true, then the color unknown will be printed. So let's go ahead and put this to the test. We have our VEX line tracker here, serial monitor running, and then let's begin with this black stapler. Go ahead and put the VEX line tracker up against it. Reads out black object detected. Next we have our little Wii steering wheel. It's white, so let's go ahead and put our VEX line tracker on it. White object detected. Finally, got a red notebook here. VEX line tracker on it. Color unknown. So here's our push button circuit. We have power coming from the laptop and Arduino. Over here on the Arduino we have our 5-volt pin and the ground pin. Those have jumper cables coming over to get power to the breadboard. Then pins 2 through 4 over here, those are providing power to the LEDs, and each LED has a 220 ohm limiting resistor that goes back to ground. For our push buttons here, we got 3 of them. Those each have a 10k ohm resistor that come from the positive side, as well as pins 11 through 13 that go in between the limiting resistor and the push buttons. And then each push button also has a small jumper cable giving it back to ground. So here's our push button program. At the top we have our LED and push button variables getting declared and initialized. In our void setup section we have our serial begin function with a 9600 baud rate, as well as the function of our pins getting specified. So the LED pins are all outputs, while the push button pins are inputs with pull-up resistors. In our void loop section, we're declaring and initializing the values of the value variables of the push buttons, and then we have our if-else-if statements. So if push button 1 is activated, the red LED will come on. Else if push button 2 is activated, the blue LED will come on. Else if both push button 1 and 2 are activated, the yellow LED will come on. Else if push button 3 is activated, all the LEDs will be turned off. And we have our serial print functions at the bottom that we would get our values on our serial monitor. So let's go ahead and run this. Push the first push button, the red light comes on. Second push button, blue light is on and red is still on. And then you press the first and second together, yellow light comes on. Press the third one, all of them turn off. Here's our LDR circuit. Again, power comes from the USB and laptop into the Arduino. The 5V and ground pins are being used to power the breadboard. Digital pins 2 through 4 are being used to power each LED. Each LED also has a limiting resistor that goes back to ground. Over here we have our LDR that is being powered by the 5V pin. We have a jumper cable going to analog pin A0 that's being used to get the sensor value from it. And then we have a 10k ohm resistor going back to ground. LDR circuit program. At the top we have our sensor and LED variables getting declared and initialized. In our void setup section we have our serial begin function with a 9600 baud rate, as well as the LED pin functions getting specified. They are all outputs. In the void loop section we have our sensor value getting declared and initialized using the analog read function, as well as a serial print function being used to print out the values on our serial monitor. And then we have our if-else statement, where the sensor value is less than or equal to 10, otherwise it's dark out, all the LEDs will turn on. But if that's not true, all the LEDs will turn off. So here we go, we're going to go ahead and put it to the test. Right now our serial monitor is reading above 10, so our LEDs are off. Go ahead and turn our lights off. LEDs are on. Serial monitor reading below 10. Turn it back on. Lights are off.